Edit tonight. We're going to drift slowly across the ocean. We will move through 30 quiet facts about its water, its creatures, its hidden landscapes, and the gentle forces that shape it. There is no need to remember every detail. You can simply let the words pass by, like small waves moving along a distant shore. And at any point, you may fall asleep. The ocean will continue without us, breathing softly in the darkness. Fact 1. The ocean covers most of our planet. About 71% of Earth's surface is covered by ocean water. From space, this makes our planet appear blue rather than green or brown. The continents may seem enormous when we live upon them, yet they are more like scattered islands rising from one connected body of water. People often speak of the Atlantic, Pacific, Indian, Southern, and Arctic oceans as separate places. In reality, their waters are joined. Currents move between them. Heat passes from one region to another. Salts, nutrients, and living organisms travel through this global system. This is why scientists sometimes speak of a single world ocean. It surrounds every continent. It touches climates far inland. It influences clouds, rain, wind, and temperature. Even someone living hundreds of kilometers from the coast is still living on a planet shaped by the sea. Fact 2. Most of Earth's living space is found in the ocean. On land, life occupies a relatively thin layer. Trees rise upward, roots travel downward, birds move through the lower atmosphere, but the usable space is still limited. The ocean has both a wide surface and an immense depth. Life can exist near the sunlit top, in the dark middle waters, along the seafloor, and even beneath the seabed itself. Because of this great depth, the ocean contains the largest continuous habitat on Earth. Much of that habitat is quiet and dark. It is not filled with colorful coral reefs or crowded schools of fish. In many regions, living creatures are separated by large distances, yet life is still present. Tiny drifting organisms float in the upper waters. Soft-bodied animals pulse through the depths. Bacteria survive inside sediments where no sunlight has reached for millions of years. The ocean is not only a place on the planet, it is most of the planet's available home. Fact 3. The average depth of the ocean is nearly 4 kilometers. Standing beside the shore can make the sea appear shallow. Waves break where the water meets the land, and sunlight may reveal sand beneath the surface. But farther from the coast, the seabed descends. Across the entire world ocean, the average depth is about 3,700 meters. At that depth, there is no natural sunlight. The water is cold. The pressure is hundreds of times greater than the pressure at the surface. Mountains could disappear beneath such water. Many of the tallest buildings ever constructed would seem very small. The deepest places descend much farther still. This great depth helps explain why the ocean remains difficult to explore. A vessel at the surface can travel easily across thousands of kilometers. Reaching the bottom is another matter. Every descent must withstand darkness, cold, corrosive salt water, and steadily increasing pressure. The ocean is close to us, yet much of it remains physically remote. Fact 4. The deepest known point lies in the Mariana Trench. In the western Pacific Ocean, the seafloor bends downward into a long, narrow depression called the Mariana Trench. Its deepest measured region is known as Challenger Deep. Measurements vary slightly because the seafloor is uneven and difficult to map. The depth is generally estimated at almost 11 kilometers below sea level. If Mount Everest were placed there, its summit would still remain more than 2 kilometers beneath the surface. At the bottom, the pressure is more than 1,000 times the air pressure experienced at sea level. There is no sunlight. The temperature is only a few degrees above freezing, and yet the trench is not entirely lifeless. Microorganisms live in its sediments. Small, pale animals have also been observed in deep trenches, though the greatest depths place severe limits on complex life. A trench may look like a simple crack on a map. In reality, it is an enormous sunken landscape hidden beneath kilometers of water. Fact 5. Sunlight reaches only a small part of the ocean. The uppermost layer of the sea is sometimes called the sunlight zone. In clear water, enough light for photosynthesis may reach down to around 200 meters. In cloudy coastal water, the useful light may fade much sooner. Below this layer, the brightness slowly disappears. First, red light is absorbed, then orange and yellow fade. Blue travels farther, which is one reason deep water often appears blue. Eventually, there is no sunlight at all. Most of the ocean exists in this permanent darkness. The creatures living there cannot depend directly on plants. Many survive by eating material that falls from above. Others hunt one another. Some live around chemical sources on the seafloor. Day and night mean little in the deepest waters. The surface may glitter beneath the sun or turn silver beneath the moon. Far below, the darkness remains steady, calm, and ancient. Fact 6. The ocean contains most of Earth's water. More than 96% of all the water on Earth is found in the ocean. The rest is divided among glaciers, ice sheets, groundwater, lakes, rivers, soil, clouds, and living organisms. This means that nearly all the water visible on our blue planet is salty. Only a small fraction is fresh water that humans can easily reach and use. Ocean water is constantly moving through the water cycle. Sunlight warms the surface. Some water evaporates, leaving most of its salt behind. The invisible vapor rises into the atmosphere. It forms clouds and eventually returns as rain or snow. Some of that water flows through rivers and back toward the sea. The individual molecules may travel for years, centuries, or far longer before returning. A drop of rain falling onto a quiet field may once have moved through tropical waves, polar ice, or the deep currents of an ocean basin. Fact 7. Seawater is salty because it contains dissolved minerals. Rainwater is naturally slightly acidic because it absorbs carbon dioxide from the air. As rain moves over rocks and through soil, it slowly dissolves small amounts of minerals. Rivers then carry dissolved ions toward the ocean. Underwater volcanoes and vents also release minerals into seawater. Two of the most common dissolved ions are sodium and chloride. Together they form the substance we know as ordinary salt. The average salinity of seawater is about 35 grams of dissolved salts in each kilogram of water. Salinity is not identical everywhere. It can be higher where evaporation is strong and rainfall is limited. It can be lower near river mouths, beneath heavy rain, or where melting ice adds fresh water. The ocean has gathered dissolved material over immense periods of time. Its saltiness is not the result of one event. It is the quiet accumulation of countless rivers, rocks, rains, and geological processes. Fact 8. Ocean water is always moving. Even on a calm day, when the surface appears smooth, the water beneath it is in motion. Waves move energy across the surface. Tides raise and lower sea level. Winds push broad layers of water from one region to another. Deeper currents are driven by differences in temperature and salinity. Cold, salty water is dense. In certain polar regions, it sinks and begins a slow journey through the deep ocean. Warmer water moves elsewhere to replace it. Together, these movements form a global circulation system, sometimes described as an ocean conveyor belt. The journey is not quick. A body of deep water may travel for hundreds or even thousands of years before returning toward the surface. These currents distribute heat, oxygen, nutrients, and carbon around the planet. The ocean never truly rests. Its motion may become too slow or too deep for us to notice, but the water continues to wander. Fact 9. Waves usually move energy more than water. When a wave travels across the sea, it may look as though a large mass of water is rushing forward. In most ordinary waves, however, the individual water particles mainly move in small circular or oval paths. They rise. They move slightly forward. They sink. Then they move slightly backward. The energy continues across the surface, while much of the water remains near its original place. A floating object often demonstrates this gentle motion. It bobs upward and downward as waves pass beneath it. rather than traveling forward at the same speed as the waves. Near the shore, the situation changes. As waves enter shallow water, their lower part interacts with the seabed. The waves slow down, grow steeper, and may finally break. Then the water does surge forward across the beach. A distant storm can send wave energy across an entire ocean, arriving on a peaceful coast long after the storm itself has faded. Fact 10. Tides are shaped mainly by the moon. The moon's gravity pulls on Earth. It pulls on rock, land, air, and water. The movement is easiest to notice in the ocean because water can flow. The result is a pair of broad tidal bulges, one roughly facing the moon and another on the opposite side of Earth. As Earth rotates through these bulges, many coastlines experience 2 high tides and 2 low tides each day. The sun also affects the tides. When the sun, moon, and Earth are aligned, their effects combine and create larger tidal ranges. These are called spring tides, though they occur throughout the year. When the sun and moon pull at right angles, the tidal range is smaller. These are called neap tides. Local coastlines, islands, bays, and seafloor shapes can greatly alter the result. In some places, the sea rises only a little. In others, it moves several meters, slowly covering and uncovering vast areas of shore. Fact 11. The largest mountain range on Earth lies beneath the ocean. A connected chain of underwater mountains winds through the world ocean for more than 60,000 kilometers. It is known as the mid-ocean ridge system. This ridge forms where tectonic plates move apart. Hot material rises from within Earth. It cools and creates new oceanic crust. Over time, this process slowly widens ocean basins. The mountains are mostly hidden beneath deep water, but in a few places they rise above the surface. Iceland is one well-known example. Along the ridge, the seafloor is geologically active. Earthquakes occur, lava emerges, new rock forms in the darkness. The ridge is longer than any mountain range on land. It is a reminder that the seabed is not a flat, silent floor. It contains valleys, cliffs, volcanoes, plains, canyons, and peaks. There are entire landscapes beneath the waves, shaped by the same restless planet that shapes the continents. Fact 12. The seafloor is younger than most continental rock. Oceanic crust is constantly being created at mid-ocean ridges. It then moves slowly away from those ridges as tectonic plates shift. Eventually, much of it reaches a deep ocean trench. There, one plate may sink beneath another and return material to Earth's interior. Because oceanic crust is continually formed and recycled, very little of it is older than about 200 million years. Some continental rocks, by comparison, are more than 4 billion years old. This difference is enormous. The floors of today's oceans did not exist during much of Earth's history. Ocean basins opened and closed. Continents gathered together and separated again. Seas appeared where mountains now stand, and dry land once occupied places that are now beneath deep water. The ocean may feel timeless when we watch it from the shore. Geologically, however, its basins are changing landscapes, slowly rebuilt over millions of years. Fact 13. Underwater volcanoes create much of Earth's volcanic activity. Many volcanic eruptions happen beneath the sea, far from human observation. Along mid-ocean ridges, magma rises through cracks in the crust and cools rapidly in cold water. This often creates rounded formations called pillow lava. The outside of each mass cools first, forming a dark crust. More molten rock presses from within, producing shapes that resemble piles of heavy cushions. Some underwater volcanoes grow for long periods. Their summits may eventually reach the surface and form islands. The Hawaiian Islands were created in this way. Each island began as volcanic rock rising from the seafloor. Other submarine volcanoes remain hidden. They may release heat, gases, and minerals into the surrounding water. They can also support unusual ecosystems around hydrothermal vents. Most of their eruptions do not produce towering clouds visible from land. They unfold in darkness, under immense pressure, adding new stone to the planet. one cooled layer at a time. Fact 14. Hydrothermal vents support life without sunlight. In 1977, scientists exploring the deep Pacific discovered communities of animals living around hot springs on the seafloor. These springs are called hydrothermal vents. Seawater enters cracks in the crust. It is heated by hot rock beneath the seabed. Then it rises again, carrying dissolved minerals. Some vents release dark, mineral-rich water and are known as black smokers. The surrounding environment is completely dark. Plants cannot grow there because there is no sunlight for photosynthesis. Instead, certain bacteria use chemical reactions to produce energy. This process is called chemosynthesis. The bacteria become the foundation of a food web. Giant tube worms, clams, mussels, crabs, and other animals live around the vents. Some depend on bacteria living inside their own bodies. These communities changed scientific ideas about where life could exist. They showed that an ecosystem could thrive without direct energy from the sun, sustained instead by chemistry rising from within Earth. Fact 15. Much of the deep ocean eats falling snow. Tiny pieces of organic material are always sinking from the upper ocean. This slow fall is sometimes called marine snow. It includes dead plankton, waste, fragments of animals, mucus, dust, and other small particles. Underwater lights can reveal it drifting through the darkness like pale snowflakes. The particles may take days or weeks to descend. Many are eaten before reaching the bottom. Others are broken apart by bacteria. Only a small portion survives the long journey to the deep sea floor. Even so, marine snow is an important source of food. Many deep-sea organisms depend on it. A sudden larger meal, such as the body of a whale, can support a community for years. But most nourishment arrives as a thin and steady rain. The deep ocean receives the remains of life from above. Quietly, grain by grain, the surface world sinks into the darkness and becomes part of another world below. Fact 16. The largest daily migration on Earth happens in the ocean. Every evening, an enormous number of small marine animals begin moving upward. They rise from deeper, darker water toward the surface. There they feed on plankton under the protection of night. Before daylight returns, they descend again, hiding from visual predators. This movement is called diel vertical migration. It involves fish, squid, krill, jelly-like animals, and many other creatures. Because it occurs across wide areas of the ocean, it may be the largest regular movement of animals on the planet. The distance traveled by each animal may be only a few hundred meters, yet compared with its body size, the journey can be immense. The migration also moves carbon. Animals feed near the surface, then carry organic material downward when they return to deeper water. Every night, while human cities grow quiet, a hidden tide of living bodies rises toward the starlight and sinks again before morning. Fact 17. Many deep-sea animals produce their own light. Bioluminescence is light created by a chemical reaction inside a living organism. It is common in the ocean, especially in the dark waters below the sunlight zone. Different creatures use light for different reasons. Some use it to attract prey. Some produce flashes to startle predators. Others release glowing material into the water, creating a bright distraction while they escape. Certain fish have light-producing organs arranged along their bodies. Some squid shine from below, matching the faint light above them and hiding their silhouette from predators underneath. Tiny plankton may glow when the water around them is disturbed. At night, waves can sometimes sparkle blue as they break. The light is usually cool. It produces very little heat. In the deep sea, where sunlight never arrives, living creatures create brief stars of their own. They blink, shimmer, and fade in a darkness that has existed for millions of years. Fact 18. Sound travels farther in water than light. Light disappears quickly in the ocean, but sound can travel across great distances. Water carries sound efficiently because its particles are close together. The exact speed depends on temperature, pressure, and salinity, but sound generally moves through seawater more than 4 times faster than it moves through air. This makes sound especially important to marine animals. Whales use low-frequency calls that may travel for hundreds or even thousands of kilometers under favorable conditions. Dolphins use clicks and echoes to study nearby objects. This ability is known as echolocation. Many fish also produce sounds. They may drum, grunt, hum, or click. The ocean is not silent. It contains storms, waves, cracking ice, earthquakes, ships, animals, and distant movement. To human ears beneath the surface, some of these sounds may seem strange or muffled. For marine creatures, however, sound can reveal a world that their eyes cannot see. Fact 19. Blue whales are the largest animals known to have lived. An adult blue whale can grow to around 30 meters in length, though most are somewhat smaller. The largest individuals may well over 100 tons. This makes the blue whale heavier than any known dinosaur. Despite its size, it feeds mainly on small crustaceans called krill. A blue whale opens its enormous mouth and takes in a mass of water filled with prey. It then pushes the water out through baleen plates, trapping the krill inside. During rich feeding seasons, a whale may consume several tons of krill in a day. Its heart can weigh more than 100 kilograms. Its low calls are among the loudest sounds produced by animals. Yet blue whales can move with a slow, smooth grace. Their great bodies rise, breathe, and sink again. For much of the time, only a curved back and a distant breath reveal that such an enormous creature is passing nearby. Fact 20. Whale falls can feed deep-sea communities for decades. When a large whale dies and sinks, its body may reach the deep sea floor. This event is known as a whale fall. At first, scavengers gather. Sharks, hagfish, crabs, and other animals remove the soft tissue. Later, smaller creatures consume what remains. Eventually, bacteria break down fats stored inside the bones. This process can release chemicals that support specialized communities for many years. Certain worms, sometimes called bone-eating worms, grow on whale bones. They do not have ordinary mouths. Instead, they use root-like tissues and helpful bacteria to obtain nutrients. A single whale fall can create a temporary island of food in an otherwise sparse environment. Its body continues to support life long after its last breath. The whale once traveled through the upper ocean, carrying energy gathered from krill. At the end of its life, that energy descends and becomes part of the deep, dark seafloor. Fact 21. Coral reefs are built by tiny animals. A coral colony may look like a colorful rock or an underwater plant, but it is made of many small animals called polyps. Each polyp has a soft body and a ring of tentacles. Many reef-building corals contain microscopic algae within their tissues. The algae use sunlight to produce energy, and they share some of that energy with the coral. In return, the coral provides shelter and access to light. Over time, the polyps build hard skeletons of calcium carbonate. New generations grow upon the remains of older generations. Layer by layer, this creates the structure of a reef. Coral reefs cover only a small portion of the seafloor, yet they support a remarkable variety of life. Fish hide in their branches. Crabs move through narrow spaces. Mollusks, worms, sponges, and many other organisms find food and shelter there. A reef is a city slowly built by animals, no larger than small flowers. Fact 22. Kelp forests are not made of plants. Kelp may resemble an underwater forest, with long stems rising toward the surface and broad blades moving in the current. Yet kelp is a type of brown algae, not a true plant. It has no ordinary roots. Instead, it uses a structure called a holdfast to attach itself to rock. Gas-filled floats help lift some kelp blades toward the sunlight. Under good conditions, certain giant kelp species can grow very quickly, sometimes by more than half a meter in a single day. Kelp forests provide shelter and food for many creatures. Fish swim between the blades. Sea otters rest among floating fronds. Snails, crabs, sea stars, and sea urchins live below. The entire forest sways with the motion of the water. Unlike a forest sways with the motion of the water. Unlike a forest on land, it does not stand still in the wind. It bends, rises, and settles with every passing wave, moving as though the landscape itself were breathing. Fact 23. Sea otters help protect kelp forests. Sea otters often eat sea urchins. This simple relationship can shape an entire coastal ecosystem. Sea urchins graze on kelp. When their numbers become very high, they can remove large areas of kelp forest, leaving behind rocky regions, sometimes called urchin barrens. Otters reduce this pressure by feeding on the urchins. Where healthy otter populations are present, kelp forest may become denser and more stable. This is an example of a keystone species. A keystone species has an effect on its environment that is large compared with its abundance. The otters do not plant the kelp. They do not care for it directly. They simply eat. Yet that behavior changes the number of grazers, which changes the kelp, which changes the habitat available to many other animals. A single otter floating quietly on its back can be part of a much larger pattern, connecting predator, prey, forest, and sea. Fact 24. Some fish can change sex during their lives. In several fish species, an individual may begin life as one sex and later become another. This is a natural reproductive strategy. Many clownfish begin as males. Within a group living around a sea anemone, the largest individual is usually female. The next largest is the breeding male. If the female disappears, the breeding male changes sex and becomes female. Another male then takes his place. In some races, the pattern is reversed. Individuals may begin as females, and a dominant female may later become male. These changes involve hormones, behavior, color, and the reproductive organs. They occur because different arrangements are useful in different social groups. The ocean contains many forms of life that do not fit simple human expectations. Biology is often flexible. In the quiet shelter of a reef, a fish may change its role, its appearance, and its body, continuing the life of the group. Fact 25. Octopuses have 3 hearts and blue blood. An octopus has 2 hearts that move blood through its gills. A third heart pumps blood through the rest of its body. Its blood appears blue because it uses a copper-containing molecule called hemocyanin to carry oxygen. Human blood uses an iron-containing molecule called hemoglobin, which gives it a red color. Hemocyanin works well in cold, low-oxygen conditions, though it is less efficient in some other situations. When an octopus swims quickly, the heart serving the body may temporarily stop beating. This may be one reason many octopuses prefer crawling along the sea floor rather than swimming for long distances. Octopuses also have complex nervous systems. A large portion of their neurons is found in their arms. Each arm can perform detailed movements and respond to touch and chemicals in the water. The animal seems both centralized and distributed, one soft body exploring the world through 8 sensitive, searching limbs. Fact 26. Sharks are older than trees. The earliest shark-like animals appeared more than 400 million years ago. The first known trees appeared later, around 380 million years ago. This means sharks, in a broad evolutionary sense, were already swimming before forests covered the land. Modern shark species are not unchanged survivors from that distant era. They have continued to evolve, divide into new forms, and adapt to different environments. Some live near coral reefs. Some cross open oceans. Some remain in deep, cold water. Sharks also vary greatly in size. The whale shark can grow longer than a bus and feeds mostly by filtering small organisms from the water. The dwarf lantern shark is small enough to fit in a human hand. Their skeletons are made mainly of cartilage rather than bone. For hundreds of millions of years, Sharks have moved through changing seas, surviving mass extinctions, shifting continents, and the rise and fall of countless other species. Fact 27. Sea ice can create tiny channels filled with life. When seawater freezes, most of its salt is pushed out of the forming ice crystals. The salt becomes concentrated in small pockets and channels of liquid brine. These channels can remain unfrozen even at very low temperatures because salty water freezes at a lower temperature than fresh water. Although the environment is harsh, microscopic life can survive there. Algae, bacteria, and other tiny organisms live within or beneath sea ice. They form the base of food webs in polar regions. When sunlight returns after the dark winter, algae may grow beneath the ice. Small animals feed on them. Fish feed on those animals. Seals, birds, whales, and polar bears depend on the larger system. A sheet of ice may look empty from above. Inside it, however, there may be a narrow maze of salty passages holding small communities between crystals, darkness, and cold. Fact 28. The ocean absorbs a large amount of heat. Water can store a great deal of heat without changing temperature as quickly as land or air. Because the ocean covers most of Earth, it acts as a vast reservoir. It absorbs heat from sunlight and from the atmosphere. Currents then move this heat around the planet. This moderates temperatures, especially near coasts. A coastal winter may be milder than a winter far inland at the same latitude. A coastal summer may also be cooler. The ocean has absorbed most of the excess heat trapped by human-produced greenhouse gases in recent decades. This slows the warming of the atmosphere, but it also warms the sea itself. Warmer water expands. This contributes to rising sea levels. Heat can also affect coral reefs, sea ice, storms, currents, and the distribution of marine species. The ocean softens changes in the atmosphere, but it does not erase them. It receives the warmth and carries it quietly through its depths. Fact 29. The ocean helps produce the oxygen we breathe. Much of the oxygen added to Earth's atmosphere comes from photosynthesis in the ocean. The main producers are microscopic organisms known as phytoplankton, along with marine algae and certain bacteria. Phytoplankton drift in sunlit surface waters. Like plants on land, they use light carbon dioxide and water to build organic matter. Oxygen is released during the process. Estimates vary, but oceanic photosynthesis is often thought to produce roughly half of the oxygen entering the atmosphere each year. Not every oxygen molecule remains available. Marine organisms also breathe. Bacteria consume oxygen while breaking down dead material. Chemical processes use some as well. Still, the contribution is enormous. A breath taken far from the coast may contain oxygen that was once released by a microscopic cell floating in the sea. The organism may have lived only a few days, yet during that brief life, it joined countless others in quietly renewing the atmosphere of an entire planet. Fact 30. The ocean preserves traces of Earth's past. Layers of sediment slowly collect on the seafloor. They contain mineral dust, shells, volcanic ash, organic material, and chemical signals from the water above. In some places, these layers accumulate with very little disturbance. Scientists collect long cylinders of sediment called cores. The deeper layers are generally older than those above them. By studying tiny fossils, oxygen isotopes, pollen, dust, and other clues, researchers can reconstruct ancient climates and changing ocean conditions. A sediment core may record ice ages, volcanic eruptions, shifts in currents, and changes in biological life. The ocean floor becomes a kind of archive. It does not remember in words, it remembers through grains, shells, and layers of mud. Year after year, particles settle through the water. They come to rest in darkness, one layer upon another. And there they remain, holding quiet evidence of skies, lands, and seas that vanished long before any human was present to see them. Now our slow journey across the ocean has reached its end. The currents continue moving beneath the night, and distant waves continue folding onto distant shores. May your thoughts become as soft and unhurried as the deep water. Good night.